Hey guys, welcome to Pepcoding. So in this video, we are going to discuss another new question of arrays string series, that is sum of subsequences bits. So in this question, we'll be given an array, and in that array, what we have to do, we have to return the sum of width of all the possible subsequences, and the width here is defined as the max minus min of my subsequences. It means, let's see here. Let's suppose you were given an array of this type. So its subsequences first of all are 2, 6, 5, 2, 6, 2, 5, 2, 6, 5 and 6, 5 and empty. So we have to return the sum of the width of these subsequences, right? And width is defined as max minus min. So here width is going to be 2, 6, 5. Here max is 6, 6 minus 2, 6 minus min is 4 here. 5 minus min is 5 minus 2 here is 3. 6 minus 2 here is 4, 6 minus 5 here is 1. Right? So we have to return the sum of all these bits. Okay. So here, if I discuss about the approach, my first basic approach is My basic approach is that I generate all the subsequences for my array of size n. So my subsequences will be 2 raised to the power n. Alright. And then in all that subsequences, you have to find out the max and the min element, right? So it is going to take about order of n time, right? So it will take 2 raised to power n into n time, which is not allowed because my n can range till 10 raised to power 9. So it is going to consume a lot of time. So we are going to discard this approach. All right. Now, if I say, listen to me carefully. If I sort this array, if I make it like this, is it going to affect my answer? So let's see here. Subsequences here are going to be 2, 5, 2, 6, 2, 5, 6 and 5, 6 and empty. Width is 2, 5 and then 6. 5 minus 2, 3. 6 minus 2, 4. 6 minus 2, 4. 6 minus 1. 6 minus 5, 1. So 1, 4, 3, 4 and 2, 5, 6. Right? So from here you can see sorting the array does not affect your width. Again here you can see if my array were somewhat like this, and if I sort this, my max is 5, min is 1. Again my width is going to be max minus min, which is similar. So I can claim that if I sort array, it does not affect answer. Okay. All right. Now let's discuss further. Suppose this is my array 2, 3, 5. 2, 3, 4, 5. No, let's say 2, 3, 5. No. Okay. So if I generate the subsequences, two, 3 and 2, 3, 5 and empty. Okay. So here this 3 behave as min, right? Here this 3 behave as max. Alright, right? Here this 5 behave as max, 5 behave as max, 5 behave as max. So if we are concerned about just 3 now, okay? See here, 3 is behaving as min and 3 here is behaving as max. If I write the width here, so it is going to be 2, 3, 5 plus this width. How can I write it? 5 minus 3. This width will be equal to 5 minus 2. This width will be equal to 3 minus 2. This width will be equal to 5 minus 2. So if you see here, when 3 behaves as minimum, I am going to subtract it from my width, and when 3 behaves as maximum, I am going to add it to my width. Right? So suppose here, if I were having 4 elements here, 4 were also here. So the combination would be something like this. Let's say, only let's get concerned about the subsequences that has 3 as the maximum or 3 as the minimum. So subsequences here are going to be 2, 3 and only 2 empty will be 3. Here it behaves as max. Here 3, 3, 4, 5, 3, 4, 3, 5, 3, 4, 5. So 4 times my 3 behaves as minimum. 2 times my 3 behaves as minimum. So here the width would be something like this. 3 minus 2 let me just 3 minus 2 plus here only 3 plus 3 plus 3 minus 4. Here this 3 would behave as minimum. Let's just not get concerned about these 3's. Okay. Let's just not talk about these 3's. Okay. Now here let's just get concerned about these 3's where it behaves as min or it behaves as max. Okay. 3 minus 2. Alright. Then 4 minus 3 plus 5 minus 3 plus again 5 minus 3. Right. So 3 times it behaves as minimum because in these two it does not, it is just included with my empty subsets. It is not going to affect my width because it's neither min nor max. Alright. Okay. So here 3 times my 3 is behaving as min. I am going to subtract it 3 times. 3 times 3 from my width, and I am going to add only 1 time my width. 1 time my 3 to my width. Right. So if it behaves as maximum 8 times, so I am going to add it to my width, and if it behaves as minimum, I am going to subtract it from my width. Did you get this? Now from here, this was my array. My array was what? 2, 3, 4, 5. Okay. Now you have to just take this thing out, figure this thing out. How do I get to know? How do I get to know how many times my this array element, that is my 2, 3, 5, 4, 5, how many times my this element behaves as minimum, behaves as maximum, and how many times this element behaves as minimum. So we have to figure out this B and this A and this B. Let's see how we can figure this out. Let's say this is my array 2, 3, 4, 5, 3, 4, 5. So here in my element, I am concerned about this element. I have to see how many times it behaves as minimum, how many times it behaves as maximum. Okay. So this is at index I. So here there will be I elements before to this 3. If there will be I elements before to this 3 which are smaller than this 3, so for all the subsequences formed by these elements, it is going to behave as max. Right? And all the subsequences formed by these elements, it is going to behave as minimum. So here there would be I elements. So this I elements will be forming 2 raised to the power I subsequences, right? And these elements are equal to n minus I minus 1. So these are going to form 2 raised to the power n minus I minus 1 subsequences, right? So this is my P, I is equal to P, and this is my Q. So it will behave 2 raised to the power P times as maximum and 2 raised to the power Q times as minimum, right? And you get to know what is P, which is equal to I, and Q is minimum, which is equal to n minus I minus 1, right? So from here you get to know how many times this element behaves as minimum and how many times it behaves as maximum by just from this index and value of n. Similarly for this 4, you get to know how many subsequences will be there before to 4, for how many subsequences this 4 behaves as maximum, and for how many subsequences it behaves as minimum. Alright, so from here you get to know how many times any element in my array behaves as maximum and how many times it behaves as minimum. So I'm going to add it to my width, how many times it behaves as maximum, and subtract it from my width, how many times it behaves as minimum. And this is my element. So I'm going to, I can also write it like this: 2 raised to the power Q minus 2 raised to the power P minus 2 raised to the power P minus 2 raised to the power Q multiply my ARR of I, right, which is my element. Okay, and I am going to add it to my width because this many times it is going to be added. Because suppose here is my 3 and here is my 1, it is going to form 2 raised to the power 1, that is 2 subsequences. Alright, 2 minus, and it is going to behave as min for 2 raised to the power 2, 4. Because there are 2 elements, so it will form 4 subsequences. 4 minus ARR of 8, ARR of I is 3. So it is going to give me minus 2 into 3. So I am going to subtract, I am going to add this minus 6 to my width. Or let's suppose there was again a 1, or let's say there was 0 also. Let's say there is 3 elements for whom 3 is behaving as max. So 2 raised to the power 3, it is going to form 8 subsequences. So here if I put 8 here I put 4. So it is going to form 4 into 3. It would be, so 3 would, this 12 would be added to my width, right? Okay, because this part of my 3 is going to include me in my width. Okay, so now here we'll be writing the code. Okay, so here first of all I will be making a variable a dot size. Now in the question we have to mod the answer by 10 to the power 9 multiple plus 7. All right, 10 to the power 9 plus 7. So I'm making a mod variable here, and now I'm going to sort my a. So a dot begin and a dot end. All right. Okay. Now I will be making a power variable which is going to tell me how many numbers prior to this there will be, how many subsequences prior to this element will be forming. So if I make a power array here, if I make an array, so for this 0 it is going to store 2 raised to power 0, because for this 0 before to this 0 I can have only one subset, that is my empty subsequences. For this one I can have only 2 subsequences because that would be my 0 0 3, right? Here I will be having 4 subsequences for this one, that will be 0 0 1, right, and 1 3 0 3 0 1 3 1 3 and then 3, right? For this 2 I am going to have 8 subsequences. All right, that's why I am making a vector of type long. Let's name is power of 2, okay, which is of size n. Now my power of 2 of 0, that is my 2 raised to power 0 is 1. So let's write it here. Now I will run a for loop for int I is equals to 0. Sorry, I should be from 1. I should be less than n I plus plus. Power of I, power 2 of I is equals to power 2 of I minus 1 multiplied by 2. And again you have to mod with mod. Mod with 2. Sorry, mod with mod. Okay, now I will make a answer long, answer which is initially equal to 0. Now after that I will run a for loop for every element. So for int I is equal to 0, I should be less than n I plus plus. I will add it to add width to my answer. So answer will be equal to answer plus my power of 2 of I minus power of 2 of n minus I minus 1, right, multiplied by a of I, and then mod this with mod. All right, and then return my answer. Okay, now let's try to run this. Accepted, and now let's try to submit this. Okay, accepted. So I hope you like this video, guys. I hope I was able to make it clear to you. So I hope you like this video, and if you like this video, please like, share and comment, and thanks for watching.